and welcome to Tennessee's At-Home Learning Series. Today's lesson is for all our fourth graders out there, even though anyone is welcome to tune in. Today is the 15th lesson in our series. My name is Miss Pereira, and I'm a fourth grade teacher at Venus Steer Elementary here in Gallatin, Tennessee. If you didn't see our previous lesson, you can find it at the Tennessee Department of Education website at www.tennessee.gov/education. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons since we'll be talking about things we've learned previously. Today we will be learning about two-digit multiplication word problems in math. Before we get started, so that you can participate fully, you will need a pencil, paper, and some space to work. I'll give you just a few seconds to gather those materials. Today we're going to solve word problems that involve two-digit multiplication. Before we do that, let's review how to multiply two-digit numbers using an area model with partial products. Write the equation with me. 14 times 27 equals blank. Now, I don't know 14 times 27 by memory, so I'm going to break it up into some smaller facts so that I can make it easier to solve. So let's draw a rectangle. We know with our area model that each factor is going to represent a dimension. So let's make 14 our length, and let's make 27 our width. Then let's expand 14 out into 10 and 4 because those numbers are a little bit easier to work with. And let's expand our 27 out into 20 and 7. And then we can go through and find our partial products that will help us get our total product. So we're going to find the area of each smaller rectangle. We know area is what? Length times width. Great job. So we're going to multiply length times width. So it would be 10 times 20 here. What is 10 times 20? Great job. 200. And our length times width here. Our length is 10. Our width is 7. 10 times 7 is 70. Excellent. Down here, our length is 4 times our width is 20. I know 4 times 2 is 8, so 4 times 20 is 80. Excellent. And then our last one, our length is 4. Our width is 7. A basic fact, 4 times 7 is 28. Excellent. And then we need to go through and add up our partial products. 200 plus 70 plus 80 plus 28. And when we add all those together, we get a total product of 378. Excellent job. Area models and partial products are helpful strategies for multiplication. Today we're going to solve word problems that involve multiplication with two-digit numbers. Now we're going to explore a real-world situation that will require more than one step to solve. We will need to make sense of the problem and decide on a strategy. Okay, read this problem with me as I read it aloud. The park has a large garden with a walkway around it. The dimensions of the garden are 32 feet by 65 feet. The dimensions of the whole park with the garden and walkway around it are 52 feet by 85 feet. The park's ground crew are going to paint the walkway. What is the area of the walkway? What is this problem about? Great, the problem is about a park with a garden in the middle and a walkway around it. What information do we know? We know the dimensions of the garden are 32 feet by 65 feet. And we know the dimensions of the whole park are 52 feet by 85 feet. We know that the ground crew is going to paint the walkway. So what are we trying to find? we're trying to find what is the area of the walkway because that's what they're going to paint. We need to figure out how much paint they're going to need to paint that area. So drawing a picture can help us make sense of a problem. Let's draw what's happening in this situation. Draw with me. First, I'm going to draw a rectangle to represent the garden. So I'm going to draw a pretty big rectangle here. But I know that the walkway is going to go around the garden. So the garden rectangle doesn't need to be quite as big. So here's my rectangle to represent my garden. And what were the dimensions of the garden? 32 feet by 65 feet. So let's label our dimensions. Length of 32, a width of 65. Now let's draw a picture of the whole park. The problem told us that the walkway goes around the garden. So what are the dimensions of the whole park with the walkway around the garden? Correct, 52 by 85. So let's draw that. And label our dimensions, 52 feet by 85 feet. Notice that these dimensions are bigger than the dimensions of the garden. The walkway is going to look like a larger rectangle that surrounds the garden. Draw it with me. Remember, we're trying to find the area of just the walkway. So what is a strategy that we could try? I'm hearing some excellent ideas. One strategy is to find the area of each rectangle that we just drew. Then we can subtract the area of the smaller rectangle, the garden, from the larger rectangle, which is the whole park, including the portion of the park. Let's give it a try. I'm going to label, just so we don't forget, that this purple one represents our garden, and the red represents the whole park. And then we've got our walkway going around the garden. First, we will find the area of the garden and the walkway together, which is the whole park. The dimensions on the whole park are 52 feet by 85 feet. How do we find the area of a rectangle? You got it. We multiply length times width. The dimensions of the park are the length and width. We need to multiply 52 by 85. These are big numbers, so we might want to use an area model like we did earlier in the lesson to help us. So let's draw an area model to multiply 52 times 85. So I'm just going to go down here and kind of draw a smaller scale. Okay, so I'm going to find the area of the whole park by using an area model. So the whole park, we said, is 52 feet by 85 feet. So if you'll draw that on your paper. Then we need to break up the factors 52 and 85 to some friendlier numbers. 52 in expanded form is 50 and 2. 85 in expanded form is 80 and 5. And then I'm going to go through and find my partial products so that I can find the total product. So I'm going to start with my length times width here, 50 times 80. I know 5 times 8 is 40. So 50 times 80 is 4,000. My length is 50 times my width 5. We know 5 times 5 is 25. So 50 times 5 is 250. My length here is 2 times my width here is 80. 2 times 8 is 16. So 2 times 80 is 160. My length here is 2 times my width here is 5, which is just a basic fact. 2 times 5 is 10. Then we can add our partial products together to figure out what is the area of the entire park. And you should have gotten 4,420. Great job. So on our model here, we can write area of whole park equals 4,420 feet squared. Next, we're going to find the area of just the garden. The dimensions of the garden are 32 feet by 65 feet. Again, we will multiply. Let's try using only the partial products this time, instead of actually drawing out the entire area model. So let's think about our garden. The dimensions were 32 by 65. So write that vertically on your paper with me. We know that 5 times 2 is 10. We know that 5 times 30 is 150. We know that 60 times 2 is 120. And we know 60 times 30 is 1,800. Notice I kept my place values lined up so that when I'm ready to add my partial products together, I can do so easily. Ones, tens, hundreds, and my thousands. So we can see that the area of the garden is 2,080 feet squared. So I'm going to go ahead and record that information. Our last step is to subtract the area of the garden from the area of the entire park to find the area of just the walkway. So we want the area of just this shaded part. So we need to take away the garden because they're not going to paint that. So we can go over here to the side. We take the area of the whole park, 4,420. Then we take away the garden, the area of the garden, 2,080. And we are left with 2,340 feet squared for the area of the walkway. So now they know just how much they need to paint. Okay, let's do another problem together. Some students are doing a charity walk to raise money for their school. Sponsors donate $25 for each mile walked. Susan walked 12 miles and Maxine walked 5 miles. How much total money did these two students raise? What information do we know? We know that sponsors donate $25 for each mile walked. And then we know that Susan walked 5 miles, or Susan walked 12 miles. Maxine walked 5 miles. And what are we trying to figure out? How much total money did these two students raise? So how much money did they raise together? So again, one of those two-parters. So what's a good plan for solving this problem? I'm hearing some great ideas. Since sponsors give $25 for each mile walked, we'll multiply the number of miles times 25. We can do that by adding the number of miles the two students walked together and then multiply that amount by 25. So we know that Susan walked 12 miles. And we know that Maxine walked 5 miles. So together, they walked 17 miles. And then for every mile they walked, sponsors donated $25. So how are we going to figure out how much money they raised? Correct. We're going to do 17 times 25. And we can do that using our partial product. So let's write this vertically on our paper, 17 times 25. Okay, we know 5 times 7 is 35. Great job. We know 5 times 10 is 50. We know 20 times 7 is 140. And we know 20 times 10 is 200. Excellent. And then we simply add our partial products together. Ones, tens, and then our hundreds. And we can see that all together, they were able to raise $425. Great job. Okay, let's try another one. Jared delivers 63 newspapers each Monday through Saturday and 78 newspapers each Sunday. Last month consisted of 4 Sundays and 26 other days. How many papers did Jared deliver last month? What information do we know? Well, we know Jared delivered 63 newspapers on 26 days because it told us 63 newspapers Monday through Saturday. So 26 days of the month, he delivered 63 papers. But it also told us that on Sundays, he delivered a few more. He delivered 78 papers on Sunday, and there were 4 Sundays in that month. So what are we trying to find? We're trying to find how many total newspapers he delivered. So what's our plan for solving this problem? Good thinking. We can multiply 63 by 26 to figure out how many newspapers he delivered Monday through Saturday. Then we can multiply 78 times 4 to figure out how many papers he delivered on Sundays. And then we can add those together. Give it a try. Remember, you can use an area model or partial products to help with the multiplication. I'll give you 3 minutes to work this on your own. Let's check your work. I did 63 times 26 to figure out how many papers he delivered on Monday through Saturday. Here's the partial products I got and my total product of 1,638. But I can't forget about the 78 newspapers he delivered on the 4 Sundays. So again, I can use my partial products. 4 times 8 is 32. And then 4 times 70 is 280. Add together my partial products. I get 312. Then I have to add the Monday through Saturday papers together with the Sunday papers. And we can see that altogether he delivered 1,950 newspapers. Great job. Okay, I have one more for you to try before I send you with some independent work for today. And let's read it together. On her vacation, Julia filled 3 memory cards with pictures. Each memory card holds 28 pictures. Julia printed 2 copies of each picture. How many pictures did Julia print? I'm going to give you some time to work and then we'll check it together. Great job. Okay, let's check our work. So we know that she filled 3 memory cards and each memory card could hold 28 pictures. So we needed to start by doing 28 times 3 just to figure out how many pictures she actually took. We know 3 times 8 is 24 and 3 times 20 is 60. So altogether she took 84 pictures, But then it told us that she printed 2 copies of each, so we needed to double that 84 or multiply by 2. We know 2 times 4 is 8. And we know 2 times 80 is 160. So altogether, she printed 168 pictures. Excellent work today. Now I have some independent practice for you to do on your own. You can get this off the screen, or you can go online to www.tennessee.gov/education for a printable version. Thank you again for inviting me into your home. I've enjoyed learning with you today, and I can't wait to see you on our next Tennessee at Home Learning Series lesson.